certain volume of gas at 298 Kelvin is heated such that its volume and pressure are now 4 times their original value. What is the new temperature? This is also another question on gas law, but in this case, we'll be applying the general gas law, which is also referred to as the combined gas law. It is combined gas law because it has to do with the volume, the temperature, and the pressure of the gas. The general gas law, the combined gas law, states that for a fixed mass of gas under any set of conditions of volume, pressure, and temperature, the value of PV over T must remain constant. Solution. This simply means that PV, which is the pressure and the volume, divided by the temperature T, must remain a constant, that is equal to K, which is the constant. So this is now being referred to as the general gas equation. Now in cases where we are being given an initial value and a final value, the equation will then be changing to be P1V1 over T1 to be equal to P2V2 over T2. Now after doing this, that is after writing out the equation which we'll be using in solving the question, the next thing to do is to write out the values from the question. So let's start with the initial values, P1. From the question, we are not given the exact value of the pressure. P1 is the initial pressure. We are not given the exact value of the initial pressure, and neither are we given the initial volume. But we are made to understand that it increases 4 times their original value. So then we'll be taking P1 to be P millimeter mercury. So we'll be representing the initial pressure with P. So P1 is P millimeter mercury, the unit of pressure. Then V1, the initial volume, same thing applicable to the volume, we'll have that as V centimeter cube. So we let our V1 to be V. So we have V centimeter cube, centimeter cube here, the unit of volume. And then the temperature, T1, the initial temperature, is 298 Kelvin. So we have that. Now for the final pressure, volume, and temperature, now we have P2 to be, we said it's been increased to 4 times the original value. So if the original value, that is the initial value, is P, definitely the final value will then be 4P, that is 4 times the initial value. So we have P2 to be 4P, the unit millimeter mercury. Then V2 now, just as the pressure now, V2 also will be 4 times the volume, that's 4V. We have 4V, the unit centimeter cube, and T2, from the question, T2, that is the final temperature, which we can also regard to as the new temperature based on the question given, remains unknown, because that's what we are being asked to calculate. The question says what is the new temperature. So T2 remains unknown, and let's proceed. So after writing out the values, the next thing to do is to make the unknown the subject of the formula from the equation. So here we now have T2 equals P2V2 multiplied by T1 divided by P1V1. So let's substitute. We have P2 to be 4P millimeter mercury and V2 to be 4V centimeter cube multiplied by T1, which is 298 Kelvin, all divided by P1, P millimeter mercury, multiplied by V1, which is V centimeter cube. So let's calculate this. Here we have 4 times 4 times 298, and that's give us 4968. So we have T2 to be 4968 Kelvin. And mind you, this V here will be cancelling out the V here as well. Same thing for the P, that is the variable we used. So now we have T2 to be 4968 Kelvin, which means that the new temperature of the gas is now 4968 Kelvin. So please, I would like to oblige us that we subscribe to this channel and also click on the notification button as well, so as to get notified as soon as new videos are being posted here. Thank you very much.